Now we will discuss some questions based on different concepts. So our first question is the number of integral solutions of x1 into x2 into x3 into x4 is equal to 210 is option A is 4 raised to power 4, option B is 6 into 4 raised to power 4, option C is 8 into 4 raised to power 4 and option D is 10 into 4 raised to power 4. So here we have to find out number of integral solutions of this equation. X1 into x2 into x3 into x4 is equal to 210. So our equation is x1 into x2 into x3 into x4 is equal to 210. So number of integral solutions of this equation we have to find out. So here our number is 210. So let's first find out prime factorization of this 210. So this 210, this can be divided by 2. So this will be 105. Now this 105, 5 plus 1 is 6. So this will be divided by 3. So we'll get what? 35. This will be divided by 5. So we'll get 7. And this will be divided by 7. So we'll get 1. So this 210, this can be written as 2 into 3 into 5 into 7. Okay. So now this x1, this can take values 2 or 3 or 5 or 7. 4 values this can take. So 4, x2 also can take 4 values, x3 also can take 4 values and x4 also can take 4 values. So this will be 4 into 4 into 4 into 4, that is what? 4 raised to power 4. So this will be what? Number of solution of this. Okay. So this will be what? Number of positive solution for this equation. x1 into x2 into x3 into x4 is equal to 210. Okay. Now to find out this, we can use another method also. Okay. For that method, okay, we'll assume this x1 as what? This in this x1 there can be factors of 2, 3, 5 and 7. So I'm taking this as what? 2 raised to power a1 into 3 raised to power b1 into 5 raised to power c1 into 7 raised to power d1. Okay. So all combinations of this I have taken. Okay. Factor of 2, 3, 5 and 7 in x1. Now x2 can be 2 raised to power a2, 3 raised to power b2, 5 raised to power c2 and 7 raised to power d2. In x2 also factors of 2, 3, 5, 7 can be there. So I have taken it like this. In the same way, x3 will be 2 raised to power a3, 3 raised to power b3, 5 raised to power c3 and 7 raised to power d3. And x4 can be 2 raised to power a4, 3 raised to power b4, 5 raised to power c4 and 7 raised to power d4. Okay. Now this x1, x2, x3 and x4, this I will put here. Okay. And this 210 that can be written as 2 into 3 into 5 into 7. Okay. So when I'll put these values in place of this x1, x2, x3, x4 here. So this 2 power of 2 will be what? a1 plus a2 plus a3 plus a4, because in multiplication if base is same the powers are added. Okay. So a1 plus a2 plus a3 plus a4, okay, that's what power of 2, and in right hand side power of 2 will be what? 1. So powers of 2 we can compare. Okay. So by comparing powers of 2 in left hand side and right hand side, I will get what? a1 plus a2 plus a3 plus a4 is equal to 1. Okay. Both sides power of 2 I have compared. In the same way, power of 3 if I'll compare, so I'll get what? b1 plus b2 plus b3 plus b4 is equal to 1. Power of 5 if I'll compare in left hand side and right hand side, so I'll get what? c1 plus c2 plus c3 plus c4 is equal to 1. And power of 7 if I'll compare, so power of 7 will be what? d1 plus d2 plus d3 plus d4 in the left hand side. So d1 plus d2 plus d3 plus d4, and in right hand side power of 7 will be what? 1. Okay. So these 4 equations I have got. Okay. Now solution of these equations, to find out that, I know solution of this equation will be what? That will be 1. Solution of this equation will be what? 1 plus 4 minus 1 c4 minus 1. How I got this? Because I know solution of equation P1 plus P2 plus P3 plus P4 is equal to n. If I want to find out what number of positive or non-negative solution of this equation, okay, so that will be what? That will be this n plus number of variables here, that is 3 minus 1 C